So our final talker for today is Davide Rossi from Chip IT.
Thank you for the kind introduction. So my name is Davide Rossi. I'm the director of a research line called Digital Design and Open Hardware. And I'm also a professor at University of Bologna. This presentation is divided in three different parts. In the first part I will present ChipSit, which is a new research foundation focused on chip design in Italy. In the second part I will describe a little bit my journey in open source hardware from the beginning to the research line in ChipSit. And finally I will describe the let's say research challenges and what we will do in ChipSit. So ChipSit is a new research center which is focused on semiconductor design. It is founded by three ministries in Italia, MIMIT, MEF and more, with around 25 million euro per year. And the purpose of this research center is basically to fill a gap that was present in Italy with respect to all the other European countries. As has been mentioned in previous presentations, every European country has a center similar to this one. In Germany there is Fraunhofer, in France there is CA, in Belgium HIMEC, in Finland VTT. Italy was lacking one. So the ministry decided to found this center with some missions. So from the strategic point of view, the first mission of the center is to do research in order to promote the design of semiconductor. Other research centers in Europe are also focused on let's say fabrication facilities and packaging facilities. For example, CA has fabs for developing FD-SOI technology. HIMEC has fabs to develop very deep submicron technologies such as 2 nanometer. Fraunhofer has packaging facilities. In order to focus, let's say, on the added value technology, Italy decided to focus for the time being on the design only. This is why at the moment in ChipSit there are no fabrication facilities, but it's focusing only on design. The second mission of ChipSit is strengthening the ecosystem in Italy. So basically it is meant to be the reference point for all semiconductor design for universities and companies. Third mission is to be the European reference with respect to the CHIPS, JU and other organizations in Europe managing chip design. And the last but not the least, not important, less important mission is to try to reduce the talent gap, trying to promote the electronics mainly at the high school level, where we are lacking a lot of students. So there are also technical objectives. I will talk about the technical objectives later. So basically, the foundation of ChipSit is from 2022, from the legal point of view. But the operation actually started just in August 24, when the director started. Then we had the first funds on November 24. And in January 25, basically with the first round of funding, we had the possibility to start the hiring. And today we have around 50 people working in the center. We have a management team which is composed of the director. We have one person which is managing the relationships with the industry, which is, let's say, a key role in order to understand the needs of the local industry. We have a person managing the relationship with the ministries and European staff, and we have around 25-30 researchers spread in 3 different research lines, and 11 PhD students spread among Italy. In terms of location, I will talk later about it. We have the headquarters of the center is Pavia, and we have a second site in Bologna. And in terms of infrastructure, we have been able in this short time to set up all the necessary infrastructure, let's say, to be able to design chips end-to-end. So we have all the EDA tool from Siemens, Cadence, and Synopsys, which are the main EDA vendors, actually the only ones. We have PDKs in advanced technology nodes. We have GF12, GF22, and TSMC 7. And we are acquiring advanced equipment, such as an emulator and advanced tester. An emulator is basically a very advanced verification infrastructure that allows to speed up the verification of digital circuits by more than, let's say, 1,000 times with respect to traditional methodologies. And just to understand how powerful is this, basically nobody in Italy at the time being has one of these equipments. ST Microelectronics has 2 of those, but they are not in Italy. They are in France. And since chipset has a central role in semiconductor, one of the objectives is to have the best equipment and to be able to share with the local industries and universities for research purposes this equipment if needed. So as I was mentioning, we have a main site in Pavia, the temporary site in Bologna. We are hosted by Cineca, and we are going to move for the site in Bologna in the final site, which is in Dama Tecnopolo, which is the same site where the Leonardo semicomputer is hosted by Cineca, and also 2 quantum computers. There will be a very big pool of technology centers. We are starting discussions with a lot of companies. We have ST Microelectronics, Ferrari, and Leonardo participating to the scientific committee. We are starting to having discussions with companies and the industrial ecosystem with more than 28 contacts and signed NDAs to start discussions. And we have 4 active European projects, basically all the pillars of the European Chips Act, design platform, competence center, and pilot line, plus a couple of others research projects related to processor, RISC-V processor developments in the automotive fields, where we are collaborating with ST Microelectronics and Stellantis. From the research point of view, actually we have 3 active research lines. One research line is radio frequency to terahertz. One research line is on analog design. We are going to activate soon a research line on power electronics. Also, we are going to have a research line in advanced packaging, so 3D architectures, chiplets, and heterogeneous integration. And let's say one of the most important part of chipset is the infrastructure and AI-assisted EDA. So basically, I come from the university, and I know that, let's say, in order to be able to do advanced chip design, you need a very strong technical team that can support the researchers in the design of chips. And this basically means maintaining the EDA tools, maintaining the PDKs, maintaining the advanced equipment such as the emulator and the testing equipment. And it's very difficult for the universities, especially for, let's say, generalistic universities to have this kind of infrastructure. So this is one of the reasons why ChipSICT was born, and one of the missions is to centralize in Italy all this infrastructure and share this infrastructure with the ecosystem. So I'm from the digital design and open hardware research line. So I'm going to talk about this, why we have a digital design and open hardware research line, and where my expertise on this topic come from. So basically, my journey in open source hardware started in 2013, where we decided to start a project which was called PULP. Actually, it is still called PULP. It was a collaboration between University of Bologna and ETH Zurich. And as mentioned in the previous talk, the goal of this project was to start developing hardware with no restrictions. So at that time, basically, there were no open source processors, or very few open source processors. So on the right, you can see a table I made the first month when I started to work on this project, because at the beginning we didn't want to develop our own open source processors and compiler, but leverage the existing one. But let's say the situation was not so good. There was one processor which was written in Verilog in a quite decent way. It was called Open RISC. And we decided, let's say, to start to work on this processor. Basically, it was the only one with a community behind it. So I decided to go to the Open RISC conference in Cambridge in October 2013, and the community around this processor was that one, which is a little bit funny if we look at what RISC-V is today. So in that conference, we presented our first results related to our core. We optimized a little bit the processor to fit our needs, which was basically creating a highly efficient cluster of processor for near sensor computing, basically a high performance microcontroller. So after that, we heard about RISC-V, and we wanted to understand, so what is this? So I personally went to the first RISC-V summit. It was in Monterey in 2015, and let's say the situation looked a little bit more interesting, because even if I never heard about RISC-V before, when I went there, there were, I don't know, all these people. And all these people, they were not academic. They were coming from big companies, from US, okay, NVIDIA, a lot of big companies. So we started to put the effort on a new processor based on RISC-V, and it was really a pain for us because, okay, we developed a first processor based on OpenRISC, and then we had to move all the extensions we did to the processor to the RISC-V ISA, and even more painful, rewrite completely the compiler. So we developed first a compiler based on LLVM for OpenRISC, and then we migrated to GCC for RISC-V. It was a pain, but it worked, because at the same time we saw that also the open source hardware, not only the open source ISA, started to, let's say, penetrating into the main industrial conferences in US. So we got a paper accepted at OTSIPS 27, it was in 2015, and at that conference we started to see some open source contributions. It was, I mean, not very common at the time to see open source hardware contribution, and also this conference was, let's say, a very highly industry conference, not an academic one, just to highlight the importance of that open source hardware was starting to have in industrial ecosystem. So, okay, you have seen this already. Now the RISC-V ecosystem is extremely big. The industrial penetration is huge. But let's say that open source ISA is not only open source hardware, it's just a prerequisite. So in the Pulp project, we started then to create a set of IPs, starting from processor IPs, 32-bit processor, 64-bit processor, peripherals, interconnect, accelerators, and all whatever was needed to create systems from single-core microcontrollers, multi-core microcontrollers, or let's say more advanced and high-performance processors, and accelerator for different purposes, from AI to more common, let's say, digital signal processing algorithm. And I would say, most importantly, in these years, we validated on silicon all those IPs. And these basically show the maturity of these IPs in order to be fabricated in different technology nodes, from 130 nanometer to 7 nanometers. This is the last one we taped out in August last year. And with these IPs, we contributed also some, let's say, industrial foundations, such as Open Hardware Group that was described by Max earlier. Let's say that a large number of the IPs present in the Open Hardware Group, for example, RISC-V processor is CV32E40P, Ariane is CVA6, the Core 5 microcontroller is Pulpissimo. Okay, so starting from this background, what we plan to do in chipset is, let's say, to use this set of IPs to do research, but let's say that the goal of chipset is not to overlap with the research done at the university, which is typically focused on fundamental research with the goal of mainly publication. or industrial research. So the goal of ChipSit is to do applied research similarly to the other RTOs in Europe, and try to fill the gap between frontier research and commercialization, increasing the TRL of those IPs developed at the university and translate them into industrial prototypes, advanced prototypes. So let's move, let's say, to the technological challenges we want to tackle in ChipSit. So basically our goal is to develop advanced computing devices in different fields, and one of the main challenges in this field is the energy efficiency. So let's say even in very different compute domain, from robotics, wearables, smart glasses, or drones, there is a need to compute, let's say, very high intensive workloads with very low power, and this lead to big energy efficiency. And the second problem is the model size and complexity related to artificial intelligence. So basically, in all the applications we are working on, there is a part which is artificial intelligence and a part which is not. And one of the problems of AI algorithms is the model size, which very often cannot fit the needs or the requirements of microcontrollers, both in terms of memory requirement and power envelope. And let's say we had in the last few years also a very big wave of AI algorithms where the number of parameters of model increased even more, and this is the second big challenge. The other challenge is related to the flexibility. The kind of compute patterns that are present in the models are evolving rapidly, and as I was mentioning, basically there is no real application, at least in the embedded domain, where you can use only AI algorithms. So this calls for architectures which are needed to be very flexible and that can be adapted with for different application domains. And let's say in this context, RISC-V present a very flexible architecture that can be used to extend cores, both in the host side of the architectures, in the compute side of the architectures, allows to have accelerators connected to the cores, or accelerators connected to the memory, for example, to target memory-bound application. One point I want to make, and we are targeting also in the digital research line of ChipSit, is the software stack. So since we want to target end-to-end applications, we are not working only on hardware. Because if you work, I mean, every component in our systems is software programmable. So if you don't have a very mature and powerful software stack, you cannot target the ITRL and have an impact. And this is why part of the effort, part of the team is focusing on software stack. We have also a PhD student in Politecnico di Torino working on these topics. So what are the applications we are targeting right now, and what are the main industrial partners we are talking to? So the first one is Essolir Luxottica. We have an almost signed contract with them, and the target of this is to develop the new generation chips for augmented reality and virtual reality application in Luxottica. We are also having discussions related to robotic application with IIT. We are in some European projects with ST Microelectronics and Stellantis, and we are having discussions with companies in the space domain and in the HPC domain. Nothing, let's say, concrete for now. Last but not least, one of the roles of ChipSit is to be the central point also for the academic ecosystem and collaborate, let's say, with the universities to promote the knowledge of design of semiconductors. So we have some grants available in the national PhD in microelectronics, and these grants, let's say, can be assigned to different universities. We have 2 grants at the moment with the Politecnico di Torino. We are collaborating also with other universities in Italy. We are planning to, let's say, extend our collaborations to many universities, and the target is to have 10 PhD per year spread among all the universities, and in order to have basically 30 active overall. So last point, I'm from Bologna, so next year, this year, RISC-V Summit will be in Bologna. I'm in the local committee. So if you want to submit papers to the RISC-V Summit, the submission is still open for 1 more week. We had 1 week extension. Thank you.